If you shaved a chimpanzee, you would find something strange underneath. Skin almost identical to yours. Pale, thin, covered in sweat glands built for a body that runs. Now look at yourself. No fur, no thick coat protecting you from the sun, the cold, the biting insects that every other primate on Earth has to deal with. Somewhere in the deep past, one ape lost almost all of its hair, and it happened to be the one that would eventually build cities, write books, and ask questions about itself. The strange part is this. For over a century, scientists could not agree on why. Some blamed water, some blamed heat, some blamed sex. And the real answer, pieced together only in the last 2 decades through genetics no one thought to check, is stranger than any of those old guesses. To understand how bizarre this is, you have to picture the world about 7 million years ago, when our ancestors still looked almost entirely like apes. Thick hair covered their bodies, just like every other primate swinging through the forests of ancient Africa. Fur wasn't a flaw back then, it was armor. It blocked sunburn, kept body heat locked in during cold nights, and gave newborns something to cling to. Every branch of the primate family still wears it today, from gorillas to orangutans to the smallest lemurs. So somewhere between that hairy ancestor and modern humans, something forced an entire species to abandon millions of years of protective fur. And whatever that force was, it had to be powerful enough to override one of the most basic survival tools in nature. Here's the mystery that keeps anthropologists up at night. Losing fur should have been a death sentence. Without it, skin burns under direct sun. Nights become dangerously cold. Insects bite exposed flesh relentlessly. And yet, naked skin won. It spread across an entire species and never reversed. So the question isn't just when we lost our hair, it's what kind of pressure was strong enough to make bare skin a better survival strategy than the fur that had protected every ancestor before us. The answer starts, unexpectedly, with a change in how our ancestors moved. Around 2 million years ago, early members of the genus Homo began doing something almost no other primate does well: walking and running long distances across open, sun-blasted grassland. This wasn't casual strolling. Some researchers believe early humans were persistence hunters, chasing prey for hours in the heat of the day until the animal collapsed from exhaustion while the hunter kept going. That kind of endurance creates a serious problem. A body covered in thick fur working hard under the equatorial sun overheats fast. Overheating isn't just uncomfortable. In a brain-heavy species that depends on a cool, stable internal temperature, it can be lethal. So, evolution appears to have made a trade. Instead of keeping fur for protection, early humans began favoring something almost no other mammal has in the same quantity: eccrine sweat glands spread across nearly the entire body. Humans have roughly 2 to 4 million of them, several times more than a chimpanzee. Sweat only works efficiently if it can evaporate off the skin, and thick fur traps moisture close to the body, blocking that cooling effect. Bare skin lets sweat evaporate freely, turning the human body into one of the most efficient heat-dumping machines in the animal kingdom. In other words, we didn't just lose our fur by accident, we appear to have traded it for the ability to outlast almost any other animal on a hot, open plain. But here's where the story takes a turn nobody expected. If losing hair was purely about heat, why would evolution replace one problem with another? Bare skin under direct sunlight is extremely vulnerable to ultraviolet damage. This is where a completely different area of science entered the picture: skin pigmentation research. Geneticists studying a gene called MC1R found something remarkable. The version of this gene responsible for dark, UV protective skin appears to have become fixed in human populations somewhere around 1.2 million years ago. That timing lines up almost perfectly with the theory that our ancestors were already losing significant amounts of body hair by then. Dark, melanin-rich skin would have been the next necessary adaptation, a kind of biological sunscreen evolving right behind the disappearing fur, protecting a newly exposed surface that had never needed protection before. What nobody realized until much later is that this chain of adaptations left a fingerprint in an unlikely place: Parasites. In the early 2000s, a team of researchers led by geneticist Mark Stoneking took an unusual approach to a question historians thought was unanswerable. They studied lice. Head lice and body lice are closely related but evolved to live in different environments, one clinging to hair on the scalp, the other living in clothing. By comparing the genetic divergence between these two lice populations, the team estimated when body lice, and therefore clothing, first appeared. Their conclusion pointed to roughly 170,000 years ago. That number matters enormously because it suggests something important. If humans needed clothing by that point, it means their bodies were already hairless enough that fur could no longer do the job fur is supposed to do. The lice weren't just measuring the history of clothing, they were accidentally measuring the history of nakedness itself. Then researchers discovered something even more unsettling. If early humans lost their protective fur that long ago, how did they survive freezing nights, especially as populations pushed out of Africa into colder regions of Europe and Asia? The answer reveals just how much human survival depended on behavior rather than biology. Instead of evolving a new coat, humans built one. Archaeological evidence, including bone needles found at sites over 40,000 years old, shows that early humans were sewing fitted garments from animal hides, essentially manufacturing the fur they no longer grew. Culture had begun doing the work biology used to do, a shift that some anthropologists consider one of the most important turning points in our evolutionary story. We didn't adapt to the cold, we outthought it. There's also a stranger, more debated piece of this puzzle. Some scientists have proposed that hairlessness wasn't only about temperature control. It may have also become a signal, a way for potential mates to detect health, cleanliness, or resistance to skin parasites in a species where thick fur can easily hide ticks, lice, and infections. This idea, sometimes called the parasite avoidance hypothesis, suggests visible, parasite-free skin might have become attractive precisely because it was harder to fake. It's a controversial theory, and evidence for it is far thinner than the sweating and pigmentation research, but it adds an unsettling possibility. Losing our fur may not have been driven by survival alone. It may have quietly reshaped what our ancestors found attractive in each other. What makes all of this even more remarkable is how recently scientists have been able to piece it together. For most of history, this question wasn't something people even thought to investigate the way we do now. It took genetic sequencing to date the MC1R gene, DNA comparison to date the lice split, and needle fragments buried in ancient soil to reveal that clothing was filling the gap left by missing fur. Three completely different fields, genetics, entomology, and archaeology, accidentally converge on the same story, each confirming the others without knowing it. That kind of scientific alignment across disciplines almost never happens by coincidence, which is part of why researchers now feel fairly confident about the broad outline, even if the exact dates remain fuzzy. And this story isn't really about the past. Look at your own body right now. Every one of those millions of sweat glands scattered across your skin exists because an ancestor on the African savanna needed to run down prey in brutal heat 2 million years ago. Every difference in skin tone across human populations traces back to that same ancient trade between sun protection and vitamin D absorption, a trade that began the moment fur stopped covering us. Even something as ordinary as putting on a jacket is in a very real sense a modern echo of that first set of stitched hides sewn together in the cold, a habit so old it predates our species leaving Africa. So the next time you feel the sun on bare skin or shiver and reach for a coat, you're not just responding to weather, you're living out the consequences of a trade made by your ancestors nearly 2 million years ago, one that swapped fur for sweat, safety for exposure, and animal instinct for something closer to invention. Losing our hair didn't just change how we looked, it forced us to become the species that had to build everything fur used to give us for free. And in doing so, it may have quietly pushed us toward becoming thinkers, makers, and survivors in a way no amount of fur ever could.